Hello everyone, I'm Jason. In this lesson, we are going to study a formal definition of limit. Consider again the informal definition of limit. If f of x is arbitrarily close to L as x approaches c, then the limit of f of x as x approaches c is L. This definition is informal because exact meanings have not been given to these two phrases. F of x is arbitrarily close to L, and the phrase as x approaches c. Augustin Louis was the first person to assign mathematically rigorous definition of limit. The first phrase, f of x is arbitrarily close to L, means that for each number epsilon that is greater than 0, the absolute difference between f of x and L is always less than epsilon. The second phrase, as x approaches c, means that there always exists a delta such that the absolute difference between x and c is greater than 0 and less than delta. Here is the formal definition of limit. To help you understand this definition, I'm going to use an example. The limit of sin x over x as x approaches 0 is 1. So, for each epsilon that is greater than 0, there always exists another number delta that is greater than 0 if the absolute difference between x and 0 is greater than 0 and less than delta, then the absolute difference between f of x and y is less than epsilon. So we have two inequalities here. I'm going to use the vertical strip to represent the first inequality. And I'm going to use the horizontal strip to represent the second inequality. And here is a point P. It has coordinates x, f of x. So, for each number epsilon, there always exists a delta to make sure that point P lies in the horizontal strip. If epsilon is 0.1, delta equals 1, you would find that point P doesn't lie in the horizontal strip. But we can make delta smaller to make sure that point P lies in the horizontal strip. Let's set epsilon smaller. Now epsilon is quite small, and you can see that point P doesn't lie in the horizontal strip. But we can make delta smaller to make sure that point P lies in the horizontal strip. So the definition of limit is as follows. If the limit of f of x as x approaches c equals L, means that for each epsilon that is greater than 0, there always exists a delta that is greater than 0 such that if the absolute difference between x and c is greater than 0 and less than delta, then the absolute difference between f of x and L is less than epsilon. That's all for this lesson. Thank you.